This lesson is going to teach you about function notation. So function notation looks like this. So as you can see, there's a letter here and then in parentheses an x. The way that this is read is f of x. So if this was a g, it would read g of x. If this was an m, it'd read m of x. It represents the value of the function, so the equation, at the given x value. So whatever number is in the parenthesis, instead of x, it's telling us the number to plug in for x. So when there's not an x here, that's the number you're replacing the x with in the function. Okay, so let's talk about why that is. So let's say I have these two equations, y equals 2x plus 3 and y equals 3x squared. So if I were to say to you, hey, can you find y when x is 4? You would probably say, well, which one am I supposed to use, right? Am I finding this y or this y, right? There's two different equations here. So that's why we use function notation. So that way, instead of me having to say find y when x is 4, I can give this equation the name f and then put an x here. And if I want you to find what this equals when this x is 4, I would write that like this. So this sentence right here, instead of writing that out, that's what this says right here. So this is saying to take the x out and put 4 in its place and then evaluate it. So we would get 11. So then we could give this function the letter g of x. So that way when you see f of 4, you know not to plug in the x for this one because this one has a g. So think of it like we all have a name. So when I say Chris, Chris looks at me and knows I'm talking to him, right? So we all have a name. So this function notation is kind of like giving the equation a name so you know who you're talking to and which one you want to plug the 4 in for. So that's what the letter there in the front means. And again, the parenthesis number is the input value. All right, so let's go ahead and give this a try here in your notes. So it says, given f of x equals 3x minus 12 and g of x equals 4x squared plus 1, problem 1 says to find g of negative 3. So again, the g is telling us who we're talking to. We're talking to this one here. And then we're going to take the x out and plug in negative 3. Now notice when I plugged in negative 3, I put parentheses. The reason why I put parentheses is because it says that x is being squared. And if x is negative 3, that negative needs to be squared. I also put parentheses here because it says 4x squared. And when a 4 is next to a variable, it means times. So that is why I put the parentheses there. So now when we have to figure out what to do first, that's where we use PEMDAS. This helps me remember the order that I do my math computations. So the first step, the P, is the grouping, so parentheses. So when you look at this function, there is no parentheses. I put those there, not for grouping, but for multiplication reasons. Next is exponents. So we're going to do this part next. So this is negative 3 times negative 3, which is 9. And then I'm going to leave the parentheses there and bring down the 4 because this means multiply right here. Now, if we take your calculator and we try this in the calculator, if you type this in as negative 3 squared, it's going to give you the wrong answer. Parentheses are critical in the calculator because this is going to give me the answer negative 9. It's going to do 3 squared, which is 9, and bring down the negative. And it's supposed to be 9. So it's very important to use parentheses with exponents in the calculator so the calculator knows to square the negative as well. Okay, so then after exponent is multiplication and division from left to right. So 4 times 9 is 36, plus 1 is 40. Oops. 36 plus 1 is 37. Okay, so we get 37 for our answer. Now, if we bring down the g of -3, this is like the label. Think of this like a label. It's telling me when I plugged in -3 for x, we get the answer of 37. So we're not going to divide by -3. We're not trying to solve for g. We are simply just trying to figure out what this function equals when we plugged in a -3 for x. So the answer is 37. Okay, so let's take a look at problem 2. So problem 2 says f of 0. So that means we're talking to function f. So now we're using this one. And wherever there's an x, we're plugging in the 0. And then we use our order of operations. So we're going to multiply here. 3 times 0 is 0. And then 0 minus 12 is -12. So our answer is -12. So if we bring this down, this is our label. It's telling us when we plug in 0 for x, we get an output of -12. Okay. All right, so let's go ahead and take a look at example 3. Okay, in this problem, it's telling us to use function f. So 3x minus 12. And again, instead of the x, it's telling us what number to plug in. And then it says add it to the value you get for g of 4. So we're going to take function g, which is 4x squared plus 1, and take the x out and plug in a 4. So that's what problem 3 is telling us. So I'm going to go ahead and start with function g. So we're going to do exponents first. So 4 squared is 16. And I could put the dot, or I could put parentheses for times, because that's what it means when you have a 4 next to an x, multiply. And then 4 times 16 is 64, plus 1 is 65. Okay, now we're going to go over here, and we have 3 times -2, and then minus 12, and we'd get -18 plus 65. So -18 plus 65. So 47. Okay, so this is exactly the type of work that I'm looking for from you. You are allowed to use a calculator in this class, but when you turn in your work for your exams, I want to see it step by step. So that it's very clear to me. You could see that I did the exponents here, and then I multiplied. So step by step, but you are allowed to use your calculator as you do those steps. So you don't want to just put it all in the calculator and click equal. You want to show your steps so that I know that you know how to do it without a calculator. All right, next example here. It says to find h of -5. So the h is telling us that we're going to use this function. And then wherever there's an x, there's 2 of them here, we're going to plug in -5. So we have -5 squared. So I'm putting those parentheses because of the exponents. The negative has to be squared as well. If I don't put the parentheses, just the 5 is squared. And then a 4 next to an x means multiply. So I can put the dot, or I could put parentheses to show multiplication. Okay, now order of operations, PEMDAS. Parentheses, there is no parentheses here. Exponents, there's exponents, so this is going to go first. So -5 times -5 is 25. So again, with your calculator, you have to use parentheses or it won't say 25. Okay, then we have, after exponents is multiplication. So right here we have -4 times -5 is positive 20. And then 25 plus 20 is 45, minus 3 is 42. So the answer is 42. If I write h of -5 here, this is again the label. So I can write my answer like that, and this is just saying when x is -5, the function's output is 42. Okay, next one says find j of 6. So now we're going to use function j, which is -4x minus 2. So we're going to replace the x with a 6. And then order of operations, we're going to do multiplication here first. And then -24 minus 2 is -26. All right. So now number 6 says find x when j of x equals 10. So this is different. So if you look at this, all the previous problems, there's been a number in front of or in the parenthesis for x. So we plug this number in for x. Now if we look here, there is no number for x. So we have to find x. So if we have to find x, we're not going to put 10 in for x. Instead, it's saying if j of x, and j of x is -4x minus 2, so I'm going to replace the j of x with the function here. So it's -4x minus 2. So I have to find x. So I need to solve this equation. So what they gave me was the output, what the function equals. So this is a problem where it's not a substitution like the previous 5 problems, but we need to find x. So to solve for x, we're going to add 2 to both sides. And then divide by -4. And we get x equals -3. So it said find x, and we did. So if we plugged in a -3 here for x, that would result in 10. So if you just read the problem, you're less likely to accidentally put the number in the wrong spot. So if it says find x, tell yourself, I'm not putting that 10 here. It's going to go on the other side of the equation. Okay, so I'd probably pause the video and try the next 3 problems on your own, see if you understand it, and then push play and check your answers. Okay, so here it says to find r of -2. So we know we're using this function. And then we're going to take out t and plug in -2 for t. And then order of operations, we're going to multiply first. So -3 times -2 is +6. And then -8. Okay. Example 8 says to find t. So again, it's saying to find t. So I'm not going to plug the given number in for t. So it says r of t equals 1. So I'm going to take the r of t out, and I'm going to replace it with the equation. And now we're going to go ahead and solve for t. So I'm going to add 8 to both sides. And then divide by -3. And we get t equals -3. So it said find t, and we found t. So if t was -3, we'd get the output of 1. Okay, now it says to find k of 3. So now we're using this function here. And this says the opposite of t squared plus 5. So we have negative, so the negative was already there. Then we're plugging in 3, and notice I'm using parentheses because it has a squared here, and then plus 5. So the t here is being squared, and the t is 3. So if you square 3, 3 times 3 is 9. So this negative was already there. It's not going to be included. So when we put it in our parentheses, when we put it in our calculator, it's just 3 squared. So that negative was already there. We didn't plug it in, so it's not part of the t. Okay, another way to think of it as, you can think of it as there's a -1 here, and then you're doing 3 squared is 9. 9 times -1 is -9. So that's why you're just bringing it down, because -1 times anything would make negative. And then -9 plus 5 is -4.